Welcome back. In this lecture, we'll talk about logical agents, also known as knowledge-based agents. These are agents that can represent the word with some formal representations and make inference to derive new representations. It also can decide what to do based on the representations of the word. Let's start with this compelling definition from John McCarthy in his article Concepts of Logical AI published in 2000. So the idea of logical AI is that an agent can represent, so there is some representations of what? Of the word, of the goals and the current situation by sentences in logic, and decide what to do by inferring that a certain action or course of action is appropriate to achieve the goal. So we have here some representation, some in sentences in logic of the word, of the actions, of the percepts, and also some inference about what to do based on the observations and the current situation of the word. So I found this like a very good definition of what's a logical AI that actually uses the key components of what's a logical AI: knowledge representations and inference. To put things back in context, let's review Percy Young's diagram for level of AI intelligent systems. So we have an x-axis, and we classified roughly intelligent systems into reflex-based agents, state-based agents, variable-based agents, and logical-based agents. In the previous weeks, we got to see many of them. So we most recently talked about learning agents, in which an agent can learn from past experience. We also saw search agents, in which an agent can represent the word with states, and each state is a black box that doesn't have any further information. We also visited CSPs, constraint satisfaction problems, where a state is represented by an assignment of values to variables. So with CSPs, we started looking into designing agent that can actually have a representation of the word and representation of the algorithm completely different. So we started separating the domain from the algorithms. So we saw for CSPs, for example, that we can formalize the problem and then use any kind of solver. So defining the problem is a part of the domain knowledge. It's embedding the domain knowledge in this some representation. Then inference could be done with any known inference algorithm or learning algorithm. We develop here logical agents as a class of agents that can combine information that they embed in general in some sort of database called knowledge-based. So this information is being told to them, and they can use it to make inference and adapt to new environments. So we are talking today about logical agents, which is on the high level of intelligence on the axis. So the key concept here is really the concept of knowledge, which is information about the word that allow the agent to choose the good actions or decisions. So knowledge is what? Is a set of sentences. The set of sentences is expressed in some knowledge representation or some language. It has to be formal to avoid any ambiguity. So knowledge is a set of sentences about the word. A sentence is what? Is an assertion or actually a proposition about the word. A logical agent or knowledge-based agent is composed of two elements, and these are a knowledge-based and an inference mechanism. So let me present that with the database. So we have some knowledge-based that is actually represented by a set of sentences in some formal representations or language. And this is completely domain-specific, which means that we depend a lot on the domain to define what are the sentences that are relevant for the intelligent agents. We also have a set of algorithms, right, that can help us make inference, and these are actually completely independent of the domain. So we have algorithms from AI that could be search algorithms or CSP algorithms or inference algorithms that help us actually derive new sentences from existing sentences, given some new percepts to decide what to do. Okay, so we have algorithms, and these are actually domain independent, and these two components actually interact, of course. And as the agent is evolving in the environment, learning from the environment and making decisions, this happens through inference, and then this inference can lead to new sentences that are being added to the domain knowledge called knowledge base. Given these two elements, a knowledge-based agent should be able to represent the states, the action, incorporate the percepts, update the internal representation of the word, and even deduce or infer hidden properties of the word. And finally, the goal is to deduce the appropriate actions for the agent. So this kind of approach is called the declarative approach, in which we build an agent by giving it information, and this information is through adding new sentences in some representation. This is through the procedure tell. Tell the agent what it needs to know. Initially, we have some domain knowledge, and we could translate that into sentences that we feed into the knowledge base. And then, as the agent interacts with the environment, it can build its own sentences and enrich that database. And the second is to query what is known. This is through the procedure ask. Ask itself what to do. So the answers comes from, follow from the knowledge base through inference and deduction, in general, logical deduction. So here's the knowledge-based agent function that actually has as input the percept and returns an action. It also maintains a database or knowledge base called KB and a counter to indicate time. All right? So the intelligent agent here does three things. And the first one is to actually translate the percept into a sentence and tell that to the database or to the knowledge base. So this would be through translating, making the percept sentence from the percept, and tell the database that this is what I got. Okay? The second one is to decide what to do. So the agent will ask or query the knowledge base, given the new percept and the prior knowledge about the environment, what kind of actions it needs to take. So this would be where actually the agent would be deliberating and making inference about what to do. The third component is tell the database what action the agent choose. So from the program of the agent, we have, and from the prior knowledge and from the new percept, we have some decision about what actions to take, and this will be added to the knowledge base. Right? So the process will repeat as time goes on. This is the general structure of the agent. We might think that actually this looks very similar to a black box model or state-based model, such as searching from how to go from point A to point B. All right, so in this case, the agent was just searching, and it seems like here we have functions like tell and ask and make percept, so it seems atomic. And the fact that it's not, basically, for an agent to go from point A to B, it doesn't use any domain knowledge. However, if an agent knows that to go from A to B, it can use bridge 1 or bridge 2, this information could be leveraged by the agent to find the best routing or find the route from A to B. So this element that we have here are actually more granular than what it appears in the algorithm.